Or in the current talk, I would like to discuss some of the seismicity and seismotectonic and seismic hazard aspects of, especially northwestern Himalayan fold and thrust belt. Everybody knows that northwestern Himalayan fold and thrust belt, which is the Pakistani part or Pakistani part of active Himalayas, and these are seismically very active, and they have research. Uh, Recent research shows that there is a possibility that there must be bigger earthquake magnitude having more than 8 MW moment magnitude, which we consider usually. That is expected in this part of Himalayas. So my work is mostly concentrated on that part of Himalayas. This is a routine picture, and everyone, every geologist, every earth scientist is familiar with this diagram and with this uh, distribution of plate boundaries in and around Pakistan. Just to present or just to show this slide in this presentation, there are some dots which are showing in yellow color. These dots are actually showing the locations of major earthquakes which are occurring in and around Pakistan. They are occurring all around Pakistan and around the boundaries within the Pakistan and in the neighboring country as well. It must be noted that all these yellow points, which are the earthquakes which occurred um, in recent history. Recent history means in Holocene time. We do not have much history of earthquakes as earthquake seismology is comparatively a new field in Pakistan. So paleoseismology, which deals with the aging of past earthquakes, not much work has been done in this field. Therefore, this data has been compiled from various sources, and this is showing the distribution of major earthquakes which occurred in the recent past. And you can see that in Pakistan, if we see northwest Himalayan part which occurs in Pakistan, there are not much major earthquakes, large number of major earthquakes. They are not very much prominent in this part. But it must be noted that these yellow color dots, which are the epicenters of the earthquakes, they are having the magnitude limit of 7 or greater than 7. So it must be noted that 7 or greater than 7 earthquakes, they are occurring mostly in Hindu Kush part or southwest or northeast portion of northeast portion of Pakistan. We can see the other distribution of these earthquakes who are having magnitude greater than 7. They are in Balochistan and then in Makran subduction zone. So basically, if we look at the history of the earthquakes in Pakistan, then we can say that mostly earthquakes, they are occurring in northwestern part of area, and then the central or the southwestern or Balochistan, Suleiman Fault and Thrust Belt, and then there are some earthquakes which are also occurring in offshore area as well. So this is a generalized picture which is only showing the recent past history of major earthquake which are having magnitude greater than 7. Once again, this is another diagram which is only showing a sort of belt which is following these Himalayan boundary, along which major earthquakes occurred, along with dates and their magnitudes. You can see that starting from 1852, and then we have 1555, and in 1905 and 1803 dates, they are not only showing the dates of occurrence of recent past earthquakes along the Himalayan belt, but also the size of these circles or semicircles. They are showing actually the intensity or the level or the magnitude or the strength of these earthquakes which occurred in these dates. So you can see that in 2005 earthquake, Kashmir earthquake or Muzaffarabad earthquake, we say it as Muzaffarabad earthquake, but some persons call it as Kashmir earthquake. In 2005 earthquake, we can see that this earthquake actually occurred about 100 years um, back in 1905 on the same Himalayan belt. There was a major earthquake, and whose magnitude, the size of the circle, is more or less similar to the size of the circle or size of the earthquake or the magnitude of the earthquake which occurred in 2005 here in Himalayan belt. So this picture is simply showing that you can see that in again 1505 there was the largest earthquake whose magnitude was near 9 that was occurred in 1505 along this Himalayan range. And we can say that with the help of plotting the sequence of these earthquakes, we can interpret that what will be the reoccurrence interval of major earthquakes in the specific area. So by looking at this picture, we can simply say that there must be an average interval of 100 years between major earthquakes. Major earthquake means major. There is a difference technically. The word major and greater. Major earthquakes are those earthquakes whose magnitude lies between 7 and 8, whereas greater earthquakes are those earthquakes whose magnitude is lying above 8. So in our case, we are experiencing both major and greater earthquakes in Himalayan belt. So this diagram is only showing the distribution and the pattern which is carrying this Himalayan ranges, and this is showing simply showing that this mountain range is quite active, and uh, quite active is a very simple word. I must say that this is one of the most seismically active belt all over the world. So we are expecting more major earthquakes in future, near future even. There are some seismologists and there are some geologists from School of Mine. They have published their papers in Nature, and we have collaboration with them, and they are of the opinion that in near future, along this belt, uh, greater earthquake whose magnitude is greater than 8 is expected along Himalayan ranges. Now, this is the picture, and um, this is the work which actually done by that group, which I mentioned most recently. Roger Billum is actually leading scientist. Uh, he's basically a geologist, but he worked a lot on the seismicity and seismology of Pakistan and its surrounding area, especially Himalayas. So these two pictures are clearly indicating that on the right side, we are saying that how the stresses are accumulating along this Himalayan range, and what are the sizes of the earthquakes which occurred in recent past, and due to the magnitude sequence of these earthquakes, we can interpret or we can forecast that in future, if we see that near Islamabad, there was an earthquake with 8.6. So on the basis of this picture, which is showing the accumulation of stresses along the Himalayan ranges, it is expected that major earthquake will occur along these Himalayan ranges, and the location of this major earthquake, which is expected in future, is near uh, Himalayan part of Pakistan, especially near Nanga Parbat in Texas and near Kagan and in some part of main mantle thrust as well. On the other side, we can see the distribution or the differences between the stresses which are accumulating and which have been which have been exploded or which have been erupted by past earthquakes. Red color are showing the recent accumulation of stresses, and the light color is showing the magnitude of the earthquakes which occurred in recent past, which are also showing in the slide in the figure on the right side. So we can see that how much accumulation of stresses and how rapidly stresses are accumulating inside and within this Himalayan ranges. And as I can see that there is a very strong blockage of stresses near 1905 earthquake location. And as Dr. Nawaz in his speech also explained that in 1905 there was an earthquake whose magnitude was high enough, and that occurred near Reasi Thrust. So Reasi Thrust is also passing along Kashmir boundary thrust, and Kashmir boundary thrust is passing in Muzaffarabad in Kashmir area. So next major earthquake is expected somewhere in that part of Pakistan, which is whose magnitude as a seismologist we expect would be more than 8. Another diagram which is showing the detailed seismicity picture of Himalayan ranges, and once again the major earthquakes which occurred along these Himalayan boundaries. These small purple colors, if you can, if you can say purple, then I think these purple dots they are showing the uh, epicenter of earthquakes which occurred starting from 1905 till 2004. So you can see that there are small sizes dots, purple dots, and there are large sizes purple dots. And the second thing which we observe from this diagram is cluster of epicenters at some places, and at some places there is not some specific pattern of these epicenters. Like in this area of Himalayas, we are experiencing scattered pattern of earthquake, which is indicative of blind and surface faults activation. Whereas here we are having a specific cluster, specific pattern earthquakes having minor and major magnitude both. And similarly, near Suleiman Fold and Thrust Belt, we are again having a cluster, a clear cluster and clear pattern of earthquakes. So all these earthquakes, as we know, that these are generated due to some of active faults, and they are indicative that these areas where these clusters or where these epicenters are more clustered, there are faults which are more active as compared to their surrounding. So earthquake seismology, we can say, is another way by which we can interpret or investigate that what faults are active without having any geological mapping or without having any accessibility to that specific area. If we are not able to do any geological field work or cannot access that area, then there is a major tool which is known as seismology. With the help of epicentral distribution of these earthquakes, we can find out that which fault is active and what will be the extension of that fault and what is the displacement and slip vector and structural parameters which we can interpret by using earthquake data. Now this is again the repetition of the previous 3 slides. Actually, this is a summary of previously presented 3 slides. In this summary, there is one thing which was not mentioned in past three slides that was related with the depth of earthquake. As a seismologist and as a geologist, everybody believes that depth of earthquake is very important. And even if the earthquake magnitude is quite high, that is, even if its magnitude is more than 7 or even 8, but if its depth is greater, means greater means larger than 300 or 400 or 500 kilometer, we know that 700 kilometer is the maximum depth at which earthquake is recorded. So if we are having a larger magnitude earthquake, but it is occurring at a comparatively deeper depth, then it cannot be more damage. It cannot cause more damage as compared to that earthquake whose magnitude is although lesser, let's say 4 or 5, but its depth is 2 kilometer or 5 kilometer, then this earthquake can definitely be more damaging as compared to the earthquake which is having the depth greater. So in this diagram, this fact of the earthquake activity is written down, and here we can see that these different colors, they are showing the different depth ranges of earthquakes which are occurring in Pakistan, and we are concentrating not only on the Pakistan but also on the northwestern Himalayan fold and thrust belt. So if we look at the location of northwestern Himalayan fold and thrust belt, then we can see that these purple color or blue color, they are indicative of very shallow depth earthquakes. Their maximum depth range is lesser than 70 kilometer. So this is another what can I say, a very threatening call for us, that if we are having earthquakes both with greater magnitude and they are occurring at the shallow depth of maximum depth of 70 kilometer in northwest Himalayan, then definitely it is very it is very dangerous for all of us to think about it. That shallow activity or shallow magnitude earthquakes, they are more prominent not only in northwestern Himalayan fold and thrust belt, but all over the country. If you can see, then even in Suleiman Fold and Thrust Belt, we are having shallow earthquakes, and there are some intermediate depth earthquake too, but they are lying somewhere in Makran subduction zone, and there are cluster of these intermediate and deeper level earthquakes. They are in the Hindu Kush area of Pakistan. So in northwestern Himalayan fold and thrust belt, we are experiencing shallow earthquakes with majority of earthquakes, they are having the magnitude greater than 5. So this picture is only differentiating the magnitude with respect to depth of earthquakes. Now these are the faults. One of the presenter he just mentioned that uh, the fault there, Pakistan is full of faults, but every fault is not active. Um, in some of the work which is being carried out using seismological data, these about 45 active faults, 45 faults have been recognized as active faults on the basis of seismological data and seismological techniques. These 45 faults, you can see that they are numbered and their name are given on the right side. All these faults are considered active on the basis of seismological data. And if we see northwest part of Himalayas, you can see that here near Astor there are two active faults, and these two active faults, they are definitely they can cause a major earthquake in Naga Texas as well. Then near Kawan and Muzaffarabad syntaxes, and then here in near Islamabad, Magla Thrust with MPT offshoots and Northern Potwar deform zone, and then in Kohat area, we haven't find any surface or blind fault near Talagang or in Banu area, maybe due to the reason of presence of alluvium in that specific location, because alluvium um, it does not permit the seismic waves on the surface. So it it might be possible that earthquakes are generating, but they cannot be observed on the surface due to surface geology, due to presence of alluvium. Now, we in Pakistani Himalayas, we are not only experiencing the earthquakes whose focus or epicenter is lying exactly on the location where they occur. Like if an earthquake occur in Islamabad, then its epicenter must be in Islamabad. Then this is known as actual focus or epicenter of an earthquake. But in Islamabad or in Pakistan or in other part of Pakistan, we are also experiencing felt earthquake. And sometime due to these felt earthquake, we are experiencing damage and destruction, even in some parts of the Pakistan where the epicenter of earthquake, even that earthquake is not occurring at that specific location, but it is far away from Pakistan. But due to the larger magnitude and due to some tectonic or geological similarity, seismic waves they spread out in all direction, and then they can cause huge damage even in Pakistan. So these earthquakes are known as felt earthquakes. In February 2021, an earthquake occurred in Tajik, and this is known as felt earthquake because due to this earthquake, its shaking and its vibration and seismic waves were felt even in Islamabad, and all these red and all these yellow and green color, they are showing the spreading or the location where the seismic waves of this earthquake was felt. So I meant to say that in Pakistan we are not only experiencing originally focused or original earthquakes whose epicenters are lying in Pakistan, but we are also experiencing felt earthquake due to these active tectonic plate boundaries where Pakistan is situated. So Tajikistan, this earthquake is occurred most recently. This is one of the example of this such type of belt earthquakes. Now this data is showing, this diagram is showing the data which is compiled from the catalog, which was compiled in 2007, from starting from 1905 to 2007. Unfortunately, in Pakistan, we are having uh, a difficulty in getting real-time data due to inaccessibility of some seismic stations and lacking of seismic stations. Second thing is that we do not have proper observatories all around the country, and we are dependent on the observatories of WAPDA or Pakistan Atomic Energy Commission or PMD. None of the educational institute or university is having any research laboratory which is consisting of earthquake seismic stations. For the very first time, our department, I have won one HEC project, and with the help of this HEC project, I have tried to establish a lab in the department, and fortunately, I'm able to establish this earthquake lab in our department, and with the help of this lab, I then use and updated the this catalog, which was established in 2007 after the occurrence of Kashmir earthquake, and this catalog was then updated and have real-time data now available in our university. We have almost 10 strong motion sensors and 8 weak motion sensors, which are installed in our department of Earth Sciences. And this is the first laboratory which has been established on university level in all over the country. So this is one thing that we are now having the access of real-time data, original data with ourselves. We are not dependent on Pakistan Atomic Energy Commission and not dependent upon PMD or WAPDA. We have our own setup with the help of which we can cover this huge area of about 400 square kilometer. And in future, we are planning to expand this observatory more so that we can cover the earthquake which are occurring all over the country. Now, this was about the earthquake lab, and this figure is once again showing the cluster of events, combination of earthquakes which are occurring in northwest Himalayan fold and thrust belt. And once again, you can see that there are some specific patterns at some places, and some places there are hardly some events or some earthquakes they are occurring. So in northwest part of northeast part of Pakistan, once again, this is carrying the huge number of earthquakes. And as far as the area of Islamabad is concerned, because our observatory is located in Islamabad, so we are getting now real-time data of Islamabad as well. So this data is showing that the area of Islamabad in Islamabad seismicity is quite high. Now, this is a sort of example of real-time data which we obtain from any station. As I said that we have 10 strong motion sensor and 8 weak motion sensors in Islamabad in Kairizm University. Now, so this is this slide showing sort of an example of analog data which can be obtained from any strong motion sensor or weak motion sensor. All these waves, with the help of these waveform or analog data, we then try to produce uh, the different parameters like magnitude or displacement and intensity, and then latitude, longitude, and other source parameters, which with the help of which we can predict seismicity level in any area. So this is a sort of an example of real-time data which we are getting from these stations. Now this is showing the distribution of uh, magnitude contouring, and color coding shows clearly shows that moderate to low magnitude are 80% in overall northwest Himalayan fold and thrust belt. And however, although their magnitude is not so high, as I said, our catalog is depending upon or concentrating on the data which we obtained from 1905 to 2007. So on the basis of this data, we are interpreting that there are moderate to low level magnitude earthquake are more in number as compared to greater or major earthquakes. Although major or greater earthquakes, they occur in this fold and thrust belt as well, but majority of them are moderate to low level. But the strange thing is that although their magnitude is low to moderate, but the frequency of lower magnitude earthquake is quite high. Now, if we are getting smaller magnitude earthquakes on daily basis, then they can be equally dangerous or equally damageable um, if we are having an earthquake with magnitude greater than 6 or 7, and they occur after 50 years or 100 years. So high frequency is a sort of alarm for all of us to look at it, the possibility of the faults, why they are so active that they are generating earthquakes on daily or hourly or monthly basis. So frequency level is quite high, although magnitude range is moderate to low. This is the technique, seismology, which we use to find out or to differentiate or to distinguish or to separate out the faults from uh, generally located faults and the active faults. As I said earlier, that we do not have paleoseismological data, and none of the scientists have, Pakistani scientists have done any work on paleoseismology. So we are dependent on the seismological data to find out which fault is actually active fault and which fault is um, was active or which fault would be able to generate earthquake in near future. So here you can see that these arrows, they are indicative of some circles on the side of each fault. These circles, they are given numbers, and these circles are known as focal mechanism. Focal mechanism solution or fault plane solution is the only technique with the help of which we can identify the active faults and the faults or the causative fault. If an earthquake occur and whose fault plane parameter are available, and then with the help of this fault plane solution, we can find out which is the causative fault if that earthquake occurred in the congestion of or set of parallel faults, then this technique is quite helpful. And globally, it is widely adopted to identify active faults or causative faults of any earthquake, or even in nowadays, even in industry, like in Oman, I've experienced that there are some seismologists in Oman. They are using this technique for the solution to identify structural gaps or structural faults, blind faults as well, basement involvement and basement modeling and thin-skinned and thick-skinned structures involvement. All these tectonic and structural modeling, they are using and such sort of structure modeling. It is also helping in oil industry as well in order to find out the hydrocarbon structural cracks as well. So in our case, our studies shows that most of the faulty solutions, they have left lateral strike slip faults uh, trending in north northwest and south southwest direction. And whereas those earthquakes whose fault solutions are having the strike of northwest, southeast, and north northeast, south southwest trend, they have steep to shallow dipping thrust reverse faults. So it means that we are getting two type of tectonic or structural model. One is related with thrust or reverse faulting, and the other one is related with strike slip faulting. So on the basis of our investigation, which is based on fault-based solution, it is interpreted that dominance of transgressional tectonic is uh, is uh, is in Himalayas, and especially near Islamabad. In Islamabad, along Margla thrust, we are getting left lateral strike slip uh, splays or left lateral strike slip indication at very shallow depth, at the depth of even 2 kilometers. So we need to see that what kind of structure is lying or what kind of structure is carrying by MBT uh, uh, at the depth of 2 kilometer or 6 kilometer or 8 kilometer. Once again, I must mention Dr. Nawaz Chaudhry talk in which he indicated some of the tectonic features. Here, I would like to mention that we, on the basis of fault-based solution data, we interpret that in northwest Himalayas, we are experiencing transformational tectonics. So transformational tectonics, strike slip component is now playing a major role or an active role in the generation or in the production of earthquake activity. So this need to be addressed by geologists or structural geologists as well. I think we must collaborate, structural geologists and seismologists, to find out the real structural model of this Northwest Himalayan fold and thrust belt, uh, which I think which would be the first work in Pakistan to integrate seismology with structural geology, because um, I'm not a structural geologist, I'm a seismologist. So I'm using only earthquake data to interpret or to investigate the causative faults and their depths and their trend and their nature and their type. So if we integrate it with structure, then structure geologists can help us a lot in order to find out the real structure model of this area. Now, this is another example of a very important thing which we use in seismology. Whenever an earthquake occurs, we try to find out the stresses direction. And with the help of this stress direction, we sometimes investigate on the initial level, even soon after the occurrence of an earthquake, we can interpret that which can be the causative fault. So this is these are two diagrams which are taken from two sources. One is from my own source. I compiled it by myself on the left side, and on the right side we have taken it from some Indian website. Both are depending on the Kashmir earthquake, and they are indicative of stress data, which is showing the direction of the stresses which has been generated due to activation of that fault, which we believe Balakot Ba fault is the causative fault, and actually this is the surface imponent of Indus-Kohistan seismic zone, which is blind thrust and some carrying some strike slip component zone. And this Indus-Kohistan seismic zone, according to Sieber and Buster, it is lying at the depth of 10 to 12 kilometer. So we believe that Balakot Ba fault is actually the surface impression of that Indus-Kohistan seismic zone, and this direction is this fault direction as well. Once again, this is the detailed picture.
Mona, 1 minute. May I interrupt you? How much time will you take?
Just give me 5 to 7 minutes.
No, cut it short to 3.5 minutes.
Okay.
Thank you.
Okay. Okay.
Please.
Okay. So this is another stress diagram which is showing the location of the Indus-Kohistan seismic zone and Kashmir Himalayan seismic gap, which I indicated that this can be the cause of major earthquake in near future. Another view, and this is the field view, another field view of some of the faults. Correlation of fault-based solution with seismicity data and active faults. Once again, correlation of fault-based solution with real-time data and fault-based solutions and active faults. Correlation of Kashmir earthquake with three major fault-based solutions. Again, satellite image. As I said, if we are not able to access the area, then we can use seismological data as well as remote sensing data. In this case, we also try to have a satellite image on which we then try to place or try to plot the active faults, which I mentioned before. Now, this is another part of salt range and Calabar fault and fault plane solution and major strike slip faults. Then this is the zonation map of Pakistan, which was established in 2005. Then we adopted Monte Carlo simulation for the very first time in Pakistan, and with the help of this Monte Carlo simulation, we then established a PSHA, a probabilistic seismic hazard map of Northwest Himalayan fold and thrust belt, which is showing the different zones with different hazard values. This is the detailed hazard map of Northwest Himalayan fold and thrust belt with different PGA values and more hazardous or categorization into different safe or hazard or dangerous areas. Now this is another more detailed part of picture which is showing the fault zones and seismic hazard map of Islamabad and its nearby region. Values of seismic zones and peak ground accelerations, and then these are the results. Faults, their respective types and their respective magnitude which they can generate in near future. Then these are the results of peak ground accelerations of active faults which are mainly surrounding our capital city. Then again, we have Monte Carlo simulation technique generation seismic hazard map and seismic hazard curve using Monte Carlo simulation technique. On the basis of this technique, then we correlated it with the previously adopted conventional technique of PSHA, and then once again modification. This is another part of Pakistan's Ziyarat area where in 2010 a major earthquake occurred, and the seismicity of the Ziyarat area and faults. Seismic zonation of Suleiman Fold and Thrust Belt, which we carried out using Monte Carlo simulation technique. And this is the overall peak ground acceleration contouring of whole country with 10% probability of exceedance. And this whole presentation is up to 80 to 90% is dependent upon on these publications, which we have published in different journals, and most recently using Pakistani first observatory data, we are now compiling PSHA map or updating PSHA map using a Monte Carlo simulation technique. Thank you very much.